My name is Damian Honeycutt. I am with DLR Group. I'm a principal with DLR, and I was the project architect for the Bed Tower project.
I'm Virginia Sutton. I'm with Rodgers Builders, and I am the senior VDC manager and was working hand in hand with Damian throughout this project. So we're excited to show you what we learned.
Yep. So the learning objectives for today, we're going to talk about the software, why should we use prefabrication, the overall design, coordination, mock-up. We're going to talk a little bit about the warehouses and how we built all of the prefabricated components, and then ultimately some pretty cool shots of the installation. From an overall perspective, our project was 108 beds of an install of an 8-story shell core building that we were all building at the same time. So there were 3 floors of med-surg beds that were being installed, 3 floors that were shelled, an interstitial floor of mechanical, plus the podium of the entranceway and support spaces underneath. All total, it was 260,000 square foot of an addition, 27,000 square foot of a renovation. The overall budget for the project was $130 million, and the final came in at 120. So through the use of prefabrication and other means, we were able to save $10 million off of the project, and the overall construction duration was 20 months.
So we just wanted to touch on some of the software. Obviously, this is a technology group. We use BIM 360 document management, and that was through the owner's hub through Atrium, and then the design collaboration portion of that. And then they did not own glue or field. And so on the Rodgers hub, we managed the glue side and then also the field side, where we were running all of our punch list, our issues, all of our document access for drawings and model viewing and stuff was going through both of those. So, and then we use Navisworks Manage as our clash detection software. The big thing that we wanted to point out specifically about the software and how we had docs set up was the image that you see there on the right. We were a very collaborative team from the very beginning, and we were all brought on basically at the same time. Damian will talk to it a little in a bit, but we housed all of our models in the same space. So there was a lot of trust built into this entire team. The boxed Revit models that you see there, those are all of the trade contractors models, and then all the unboxed Revit models are the design models. So everybody had access to edit everybody else's models or delete them or whatever. And so that was instrumental in having that trust in order to make sure that we could operate in this type of platform and environment.
Why prefabrication? We get that question a lot, and honestly, it's why not? But some of the main key points from why you want to is the controlled environment. You are able to control the schedule. You're able to control safety on and off the site. And there is an increased speed and speed to market. The other reason or advantage is, and you don't necessarily have to have a repetitive design, and you're going to see that through the racking system. But with a repetitive design, that is another reason why you could have increased speed. You can reduce your material cost, and then, of course, hopefully eliminate any rework cost. Is this the video? Share sound. It stopped. Why did it stop?
Right now, we're on the Pineville Bed Tower project for Atrium Health here in Charlotte, Pineville.
We had just completed a similar bed tower project that was traditionally built, stick built, on exterior masonry construction. At that point in time, we started to think that there had to be a better way to improve speed of market.
There's a lot of waste in construction, and prefabrication helps us eliminate that waste, both in design and in construction. So on this particular project, Atrium Health wanted prefabrication, and they challenged us to do as much prefabrication as we could do.
Healthcare is not cheap. You all know that. How can we be good stewards of the dollar? And that is by assembling the team early and prefabricating the post, designing a building with prefabrication in mind. Where in the past it's been design a building, then look at it and say, what can we prefabricate? The thought process has to change.
Prefabrication in this part of the world is relatively new. Never been done in Charlotte before. So for us to be able to do that, our VDC department needed to grow.
VDC, or Virtual Design and Construction, is the process of taking plans for a project and putting them into 3D in a building where you can really see what you're going to do before we even start building it in the field. We have been able to create a rack that can be replicated over and over again. It's allowed us to build the racks in a warehouse on the ground so they can really pick up speed and install them quickly. And then once we bring them up to the field, so much of the system is already put together that we can lift up a large portion of what the overhead would typically be all at once, which really eliminates a lot of the time that we have invested and allows us to reduce the amount of labor and workers that we have out on the job site. Our end goal really is to just help reduce the amount of time and materials used on a project to deliver them to the owner sooner.
We immediately told ourselves we don't want to do prefab just for the sake of doing prefab. I mean, it's kind of a trendy thing to say that nowadays. We wanted to make sure it brought benefits to the project.
First and foremost is safety. Prefabrication, when you're in a controlled environment and everybody's working at waist level and ergonomically it's better for them, it's just much safer. Second thing is quality. When you're, again, in a controlled environment, you do a much better job with making all the connections properly, making sure things are passing properly, and you get a higher quality product. It also helps from a schedule standpoint because you can start this work a lot sooner. So these bathroom pods were actually under construction while we were still coming out of the ground on this structure. So that would never happen if you were stick building. Same thing with the overhead racks that's behind me. Those all started several months ago, way before the building was ready for those racks to go in.
What I think you're going to see here, not only in the Charlotte market, but other markets, is you're going to see a lot more prefabrication that takes place. The advantages to it become clearer and clearer as skilled labor becomes harder and harder to find.
This project gave us the opportunity to introduce prefabrication to the subcontractors in Charlotte. And so our hope is that they learn from this project and want to do this on other projects and help us convince other owners that this is the right thing to do.
Getting brought into something with this level of complexity was really exciting for us because Rodgers Builders is one of the premier contractors in our area and in the state.
So we know there's a shortage of labor in the industry. We're going to have to get smarter. We're going to have to use our labor more efficiently. MSS thinks that the future of commercial HVAC is prefabricated efforts. We can do more in our warehouse quicker with the same amount of guys.
10 years ago, if you looked at prefabrication in the electrical industry as a whole, it was more of a contractual obligation. Now this is a mindset. And now it's what can't we prefab?
As tradespeople, we're proud in our work, we're proud with what we do. It takes a lot of planning, it takes a lot of time invested in the project, but at the end of the day, this project will come in under budget and significantly under budget based on the type of project that it is.
It's wildly successful. You can see it here. I mean, the accuracy of those compared to the model are incredible. So the success of these racks really has contributed to Rodgers Builders and the trade partners of Performance Fire, Precision Plumbing, Adams Electric, and MSS. Without them, this would not have been possible.
But it's just amazing what we've been able to accomplish here on this job with this team to be doing it for the first time. I'm just real proud of the effort that went into this project.
All right. Moving into the design itself. And the video alluded to a lot of the prefabricated components that we had in the overall project. There were 108 toilet pods built, 108 head wall, foot wall combinations. The entire exterior envelope was panelized and prefabricated. That worked out to be 165 acrylic slash EFIS panels, and then 173 thin brick panels. And it was those panels were installed in 23 days. The electrical panels and portions of the electrical rooms were prefabricated, and then of course the multi-trade racks, and there were 27 racks over 3 floors. The goal for this project set forth by Atrium was to have 25% of the total budget be prefabricated. We ended up with, at the end of the day, 36% of the total budget. And it was just like what Mr. Schroeder was saying, it was wildly successful. Is this you or me? I think this one was you. But it's fine. So from a design standpoint, and you saw through the video, we were designing this before COVID, during COVID, and then building it during COVID and after COVID. So you saw a lot of masks and a lot of face shields. It was essentially, from a design standpoint, a 13-month process. We did co-locate. So instead of having a job site trailer, we had a 5,000 square foot space that was adjacent to the project site. And we implemented our big room meetings. You'll see the cubicles there. I was on site 3 out of 5 days of the week. Same thing with the engineering team, as well as any other design team and the major subprime contractors, all sat in this space all together as we work through the process here.
Yeah, so we had big room meetings in addition to just sitting together. And so you see that in the image on the bottom, but those big room meetings happened once a week with the whole team, about 40 people, and gave us the opportunity to talk through different ideas that everybody had and vet those out as a larger team for practicality, pricing, and then using that as direction on our design. So some of the big things we have listed there were locations of the duct shafts, which we'll look at later, electrical rooms also, along with piping shafts, and then talking about how do we make prefab with multi-trade racks work, knowing that we were trying to achieve this 25% prefab number from the design or from the owner. So we were looking at how do you have a repeatable floor plan, and what do those units look like? And so that the units for the patient rooms repeated every 16 feet. So we knew we wanted to try and look at things that would happen in kind of that magical 16-foot multiple. And then we had offset rooms, or the doors for the rooms were offset, which was very unique to our design. Damian will talk to it a little bit later too, but that definitely helped us with those multi-trade racks, also making sure that we could fit everything and fit it efficiently. And so those were all conversations that we had leading up to this and helping direct us as we kind of worked through what does a trade rack look like. And then the other big thing was permitting with fire protection, because we decided we wanted it to be a true multi-trade rack, and that included not just MEP, but also fire protection. And so that obviously gets you triggered into the seismic categories here in Charlotte, and that had never been done. And so we had conversations with the county, meeting with them to really understand what that looked like and make sure that we accounted for any additional structural calculations and stuff to make this actually work and set that precedent.
Yeah, we treated the permitting, the fire marshal and local building inspection as a teammate for this project. They had seen prefabrication from toilet pods only when it came from the hospitality industry. They definitely have never seen it anywhere else, nor to this scale. So this was new to them. So we treated them just like a team member and brought them in early and often so that they were comfortable with what we were doing.
So I already mentioned that 16-foot repeatable factor with these patient rooms. So this was a sheet that the engineers put together, trying to make sure that if we were fabricating these very long rectangular racks, and then also the bathroom pods that we fabricated, could we insert them into the building, and could we make the turning radiuses we needed in order to get past the column grids that we had, because we did not have a traditional column grid where everything was lined up in the horizontal and the vertical. So you can see here the columns are highlighted in that dark red, and so they're offset from each other to work with these slanted patient rooms. But this again was just something that we generated to have a lot of these conversations early on in that big room to help guide us.
Yeah, so let me take a quick second here and kind of break down the floor plate for you. Each floor was broken down into two units. The bottom in the left, that's a 20-bed unit, and the going vertically, that is a 16-bed unit. Each one of the rooms are same-handed. They are nested and canted. So there's really not a 90-degree angle in any one of these rooms, which also made for some very interesting construction details. But you're kind of getting this this form from a nurse station kind of layout, where you have decentralized nursing at those little Y station nurse stations. And then the area that's in the bottom right, that is essentially support space. So you kind of on stage and off stage when it comes to designing the building itself and how you utilize it.
So this, we generated A3s throughout the project to kind of finalize decisions that we made in these big room meetings, and use them as reference if we needed to on why we made a decision later on in the project if somebody asked the question. So this is the MEP shafts specifically, and one of the key things that we talked about was where do we place these duct shafts when we worked through what the racks were going to look like transferring down these corridors. And so originally at one point we had started kind of in a traditional sense where we had the shaft located in the center of the building, and that was going to support both the return air and the supply air. But as we were having these conversations in the big room, one of the big things that we started to realize when we started looking at the duct sizes to get an idea of what the layout of these racks would look like for width and height is that we very quickly understood that the largest duct all happened together at the same spot, and then the smallest duct at the ends of the corridors was all happening in the same spot. So the floor plan was revised to actually put the return duct shafts at the ends of the wings and then put the supply in the center of the wing. And so that way, as one got smaller, the other one got larger, and they could really kind of share that same space in the rack. And we didn't end up with an inefficient rack, because by the time we got to the end of the corridor, there wasn't much left on it.
Correct. And I cannot stress enough that once you make a decision like this, you document it and you move on, and you don't come back and rehash the decisions that you previously made.
So, I have a number of slides here that show some iterations of the rack. We're not going to talk through each one, but in essence, what the takeaway here is we started with an idea of a rack initially on what we thought we could do. And then as we brought these ideas to the big room meeting every week, we had this up on a large screen, and then everybody got to give their input on pros and cons that they saw, or any questions that they had, or anything they wanted to challenge us with. You can start just kind of clicking through them. And so we usually generally for the meetings would bring 2 iterations. And so then everybody could kind of rank the pros and cons between those 2 choices too.
Before you get too far. I don't want to foreshadow here, but you can see a clash already happening through the middle of the duct that's
Yeah.
running through the space with one of my designs for the soffit. So this was one of the early iterations, and this is where the back and forth kind of went through from a design standpoint and a constructability standpoint. So I'll talk more about this in a minute.
Yeah. So we ended up on an iteration 8, I believe is where we finished. So Damian's kind of clicking through them. You can see them evolve. It ended up getting larger to where we stopped at a 12-foot wide rack, or just shy of 12-foot wide, which was the stopping point that we had decided on in order to try and make sure that we were meeting DOT requirements with wide load permits and everything. And then it was 32 feet long. So again, that's that multiple of 16 for the repeatability of the patient rooms. As Damian kind of mentioned with the soffit, you'll also notice in this image in that top right where you've got the section view is that soffit has disappeared now from the center of the corridor, and it's moved back to only be 2 foot off the left wall. And that was on purpose in order to not have to worry about how do we attach a soffit wall to the bottom of that structural rack at this point. And so then once we finalized where everything was set in that 8th version, we ended up writing an A3 that just kind of summarized how we went through that whole process. So we had it all figured out where everything was going to go at that point for systems. But what we didn't have figured out was what do the connections to the deck look like? Because we had to figure out what the weights that we were dealing with were first before we could do that. So we then generated a spreadsheet that you can see here where we listed out every single system and then the links of each one of those systems. And then everybody plugged in the weights that they had, each trade, and whether it was filled with water or not filled. And then that way we were able to give this spreadsheet to the structural engineer and he could start running all of his calculations to start designing what those connections looked like. So these are the 3 details that he came up with. We had some connections that went to the deck and then some connections that went to beams. And so he had 2 different types of connections that he identified on how that would work. The big thing to take away here in that design was that we had 2 directional connection there at the deck so that we could have a 1-inch adjustment in the X and Y. So as we were lifting the rack, if it was slightly off, it had the ability to move versus having a set in bed that you were having to hit exactly. So if it had shifted during a concrete pour or something, you'd have a lot more trouble trying to get that up and then having to pause to put in a new embed or something.
So from a coordination consideration, this is kind of what I was alluding to previously. On the top right, that image was the first initial concept of the soffits that were going to be over the nurses station. This design for Atrium utilized the open core concept. And what that does, it essentially is a 16-foot wide corridor with an 8-foot circulation in the middle of that corridor. Completely different than normal healthcare design where you only have 8-foot wide corridors because that is what is required by code. So as we were trying to work through that and that initial design, we were realizing that from a coordination standpoint, as well as an access standpoint, how do you maintain it? How do you build it? How do you install it? And then, ultimately, when they live with it, all those type of considerations go into that. So the final design is what you kind of see there at the bottom right-hand side, and it's highlighted there in the orange. It was a little bit more subtle, a bit more understated, and then I was able to create that space over top of the nursing team station with a pendant light versus an overall soffit.
And so another change that happened because of these racks was the linear diffusers that had been in the corridors. The initial design had them parallel with the corridor, but because of the space that we had above the ceiling, the height of the linear diffuser was about 10 inches tall, and the bottom of our racks was actually only 8 inches above the ceiling. And so by being able to turn it that 90 degrees to be perpendicular to the run of the corridor, we were actually able to nest it up in between the frames of the racks to still have them located in the same spot, but give us that coordination there.
Architecturally, we were being really meticulous in the ceiling about how things lined up, and we wanted to be very purposeful. So it would have been really easy if we just moved it completely off-centered as needed, willy-nilly, wherever it needed to be. But ultimately, we were able to coordinate and work this through. So we were working from an aesthetic standpoint as well as a performance standpoint.
Absolutely. So once we knew where everything was going to be located on the racks and worked through that ceiling coordination, we did also need to understand how are we actually attaching all of these systems to the rack so that they knew how to fabricate everything with all the miscellaneous steel that we need to add in. And so that we spent a decent amount of time, a lot more than we thought going in, just making sure we covered all the details of exactly is everything supported at their minimum distances or less, or sorry, their maximum distances between attachment points or less. And what does that look like? And does that start to create a problem once we put those in with another system being in its way? So this is just some images of kind of all that population coming in with the hangers, the punch templates for the conduit, and the extra unistrut that was added in. So we did, in order to be able to have conversations easily with everybody and reference individual racks, we did create a drawing that showed those rack naming conventions. So we had a wing A and a wing B. So it was easy enough. We just started with the number 1 in the center of the building and then worked our way out to the end of the corridors. But that gave us the frame of reference to reference each one individually. And then we also generated structural drawings once we had all that miscellaneous steel put in for the hangers. And so this is what the first page looked like. It was 2 pages worth. And this was given to MSS, our mechanical trade, because they were the ones fabricating all of these steel frames. And then the second page looked like this. It was an isometric to give you the dimensions and the references for all of those extra pieces of unistrut that would have happened in between the different frames, the 5 frames that we had. And so then we started working on the actual rack drawings themselves. So we had 3 sheets that we generated for every single rack. So there are 27 racks because they varied even from floor to floor, even though they were basically the same floor plan. Some of the services that we were providing for the type of patient room varied a little. And so our pipe sizes or something would change from floor to floor. So the first page was everybody together. And then the last 2 pages was just split out individually by plan view and section for each individual type of system so that they could be tagged and dimensioned for easy reference. Keep going. So then we created mock-ups. So we had 3 mock-ups total. This was mock-up number 1. And then we were able to have everybody kind of give their feedback on it and how that worked, putting it together. We also learned from this one that we needed, this one was right at 12 feet wide from one side to the other of the structural rack itself. And then when MSS tried to roll it out their door, their rolling door in their warehouse was actually only 12 feet wide. And the casters that sat on this stick out a little bit beyond that 12 feet. So they couldn't actually get it out of the warehouse. They have a wider door now, but we were able to easily modify it, luckily, and bring the outer HSS members just inbound of the verticals without having to modify anything. So we really just got lucky there. And so that was mock-up 2.
I like to say that it didn't fit through the door because they didn't model the casters. And that is still on my punch list to remove the casters from the racks. And they are, yes, they are still on the ceiling.
Yes.
The other key thing I want to point out here is the gentleman that's in the hat on the far left, that is the mechanical inspector. He was brought in and reviewed the racks as prototypes, and he had input at this level as well. And then he inspected and reviewed when all the racks were completed in the warehouse before they were delivered to the site.
Yeah, so
What LOD do you think modeling the casters would take you to? That level of detail, 750.
they got left on, so technically we probably should have been clashing them, but so mock-up 2, we actually installed in a full scale mock-up of patient rooms and corridors too. It also gave the opportunity for Atrium's POM team to come in and actually walk it and look at how the rack interacted with the ceiling grid for access to everything. And they had one comment to change where they wanted the circuit setter hooked up to the VAV, but that was about it. And it really gave them that sense of confidence that they were going to be able to maintain this stuff easily because the clearances were all there.
The other thing here is, one of the other reasons why we wanted to do the rack was we were pulling anything that needed to be serviced out from over top of the patient. So everything is now inside of the corridor so that if anything ever went sideways, it could be maintained from the corridor. They would never have to affect or relocate a patient inside of one of the patient rooms.
And so then mock-up 3 was really just, there were just a couple tweaks to the actual miscellaneous steel hanger stuff. And so at that point, they just started fabricating all 27 racks. So that's 3 of them you see there. So just kind of how did it work in the warehouse itself? MSS had just moved into a new warehouse and had a nice space in the back that was empty. And so they were able to lend that space to our entire project. They gave all the other trades a 20 by 20 fenced off or 20 by 25 fenced off area within that space that they could store their tools and their materials and stuff. So they could, it was just a chain link fence that they could lock up each night and leave their stuff. And then we ran these racks in full corridor lengths, except for that 4A corridor that we didn't have the space. And that way they were hooked up the full length. There weren't gaps in the racks in between them. And that gave us the opportunity to actually pressure test everything in the full run so that we could insulate in advance of shipping it out. And then if we had a pressure test issue, once we were out in the field, once it was hooked up, we at least knew it happened in between the racks and not on a rack to try and track all of that down and rip insulation off. So this is just kind of what it looks like inside the warehouse. They did have some control points there to help them set how far apart the racks needed to be from one another and get all that lined up. They also did, they sent, one of their newbies out there that was learning how to weld all these names on. And then they also tagged them with tags so that once it was lifted up above our heads, we could still see the name of the rack. And so then for lifting purposes, they had a D-ring there that you see attached. They had 4 of those around each rack to lift it with the tower cranes. So we did generate some rack install phasing drawings also for them that they were able to print out full scale and then put up in the warehouse for everybody to reference on who had what order. And so then these are just some pictures showing that the VAVs going in first with the ductwork and then the mechanical pipe. And then the fire protection. So basically we started on the middle and worked our way out to the edges. And then we came in and put the return duct on the top outside of the rack after the fact. So we hadn't put any of that big duct work up top that would prevent people from being able to easily get to the middle level of piping to install. And so then this is just an example of that test report that we did for the pressure testing in the warehouse. And then the other big thing that we did before we shipped it out to the job site is Atrium requires asset tagging. And so we were able to asset tag all of the equipment that was on the rack while it was still on the floor and also tag all the valves. So that really saved us a lot of time not having to go up and down rack or up and down ladders on the job site above our heads trying to apply all this stuff. So they transported to site, they picked up some cranes, they transported half of them in preparation and staged them on the campus beforehand. And then they transported the rest the next day and started lifting them. So these are just some images showing that. And then skip that. They just slowly push it out. The footage was just there to stop it in case it started getting away from them so that it wouldn't continue rolling. So this is just what it looked like pre-staged. And so we had figured out how it was all being lifted in, to be lifted in order to roll to the right location without having to jockey them around. And then there's a lifting video. Is this the video? There's the video. It's sped up really fast, I think.
There it is.
Do it one more time.
I wonder if it will play better without video or without sound.
Change. Yeah, unshare sound.
Although
Okay.
the chipmunk sounds interesting. In Virginia, we can't hear you talking over the video. No. Maybe if you turn the sound off on the video.
You did. It's all right.
We'd unshared it, but okay. So, well, as this was coming in, basically what we were trying to show is that the fireproofing was already sprayed on the steel. And so we had talked through enough of the logistics to know that we didn't want to accidentally bump it off and stuff. And so they had placed the D-rings for lifting at frame 2 and 5 of these racks instead of frame 1. And that allowed us to have enough of the rack come in to where the workers could get a hold of it safely without being on the edge of the slab and get the caster set on the slab and disconnect the rigging from frame 2 D-rings without that rigging coming inbound so far that it was actually going to jeopardize that fireproofing there on the steel for us to have to go back and redo it. So these are just some images of what it looks like on the site and also the attachments that the structural engineer had done. And so then the big thing here, it was the first time we'd done it, obviously, so it takes a little while to get used to a new process, obviously. It took us 52 minutes to lift that first rack and get it set and everybody back on the ground. By the time we finished with that first floor and the 9th rack on it, we were down to 16 minutes. And then sometime between there and the 27th rack that we lifted, we were down to 9 minutes a rack. So this is 12 feet by 32 feet worth of MEPF systems that we were lifting in 9 minutes. So the significance of how fast we could install this incredibly sped up the process that we would normally have if we were having to stick build all this in the field. And then these are just some images of what that looks like. We lifted it with chain falls, you can see here, that were just wrapped around that structural attachment. So, and then once we did that, we pieced it back together. We had 1 foot sections of duct that would pop out, spool pieces. And so those got replaced back in. And then the pipe, which was the level below, was 2 feet wide with the intent to be able to give the workers enough space for their bodies to be able to get that 1 foot section of duct in without being pinched in between pipe. And so then once all that was pieced back together, they were able to run the pressure test again in the field just to make sure that they had everything hooked up well. And so then one of the takeaways we did have from all of this was actually the electrical. So there was a lot of electrical on there. And when we built it, the electrical did not come out at the same elevation that it needed to enter the rack. So you can just see in the picture here that it ended up causing a lot of bends that they had to put in the field for this portion, which was stick built out there. So that's one of the things that we learned after the fact that we like to point out for sure as a lesson learned, to take into account, but.
So, in conclusion, I know we're running short on time. We want to leave some time for questions. Virginia talked a lot about how fast we were installing all of the racks, and we got down to 9 minutes. We were able to dry in the entire building on the exterior. From when we started the dry-in process to finish, it was 11 weeks. The example that we have is of another bed tower 30 minutes away from here that was of similar size and scale. That project was stick built with brick and curtain wall and precast. It was 11 months. So we know that there was a substantial savings that could be had from prefabrication. And ultimately, at the end of the day, we were able to do that. So when you look at this from this standpoint, we were able to open the tower 90 days ahead of schedule. So with 108 patient beds that they could be billing at $1,000 a day, and that's just a really round number. And that's different depending on the modality of whatever the patient is in the room, whether it's a med surg room, which is around, $1,200 to telemetry, which is $3,000 a day, or even ICU, which is $5,000 a day. Let's just say $1,000 a day, 108 beds, 90 days ahead of schedule. Ultimately, this is allowing the owner to generate $9.72 million of revenue just by us opening early. And that was all due to the prefabrication efforts. So remember, I was asking earlier, why should you prefab? And my response was, why shouldn't you? And this is the reason why. So there's our contact information. I believe we also have it in other locations too. So
Yeah.
I think we're done. So thank you, everybody.
Awesome presentation as usual. And yes, there is in the mural. So if you're not in there already, please join us in there. It looks like we do have a few questions. I think you guys answered a few of them as well. But maybe one that maybe comes to mind, outside of being able to access all of these facilities outside of the patient room, which is a huge benefit, are there other facilities management and other kind of operating benefits or impacts that you can see?
Yeah.
I think both of these are kind of related in a way.
Yeah, one of the comments was patient comfort and sound. So if you're removing the VAVs out from over top of the patient, putting it in the corridor, they're going to have a quieter space. So that there is a benefit. We talked about the ease of construction. So we were able to centralize everything. So that was a benefit there. And then of course, the maintenance and that POM portion. They were a stakeholder and they were just as much a part of the design process as anybody else. So those were our key things. But of course, you talked about the other added benefits, like I said, the noise reduction, the patient satisfaction. And
Absolutely. Absolutely. Do you guys maintain the model through future modifications and renovation? I guess you haven't really gotten that far.
So Atrium is a more progressive client, and they actually require all the design models with updates from as-built to be handed over to them at the end. And so we were maintaining these models as we were going along throughout the entire process. So Damian's team and the engineers were weekly making sure that they were capturing any changes that had happened over the course of that week through coordination, or once we were past coordination, if there were any modifications that were happening in the field, and getting those updated so that by the time we got to the end of the project, we actually handed over these design models as record documents with the incorporated as-builts to Atrium. And then Atrium brings all of that new construction information from the models and puts it into their big master campus model. And so they manage all of that. we obviously both keep copies of all of these models in our own in-house records too, in case we need to go back to them in the future. But Atrium does utilize all of these models they collect, and they give it to the designers for the next project that they are putting out, so that designers are starting with whatever was handed over. So obviously that can be based on the quality of what the designers are handing over, and whether or not they're actually doing their due diligence to keep the models updated. But on this project, we were very intentional about making sure that we were handing over the best product that we could for them. So.
Fantastic. Well, any final thoughts? Looks like we have a minute or two that you or Damian would like to share. Thank you so much. This presentation, as usual, has been fantastic.
Yeah. I mean, you have.
No, we appreciate being able to do this. I think this is probably the fastest we've done it. Typically, we do this in like an hour and a half. So we did cut out quite a bit, and I tend to get long-winded. So hopefully I didn't bore anybody, but no, we're happy to share what we've done. And we've actually even taken lessons learned from this, because this project was completed 2 years ago now, and we've since applied some of those lessons learned, and mostly on the electrical side. We've taken with our subcontractors, and we're now prefabricating entire electrical rooms, and they're being set into 3 walls of construction, and then they built the 4th wall. We're doing complete underground utilities for electrical switchgear rooms now off-site, and then bringing those in and backfilling. So what underground would have taken 2 to 3 weeks is now being done in 3 to 4 days. So this is an ever-evolving process. It's going to continue, and there are going to be more. And it's just at some point in time, this is going to be standard practice.
I really do hope so. Well, thank you guys so much. Thank you all to our participants and attendees that were able to make it today. As usual, you'll be able to get to this recording very shortly on our YouTube channel. Thank you so much.
Well, I'll try and get these other comments that are in here on the board. I'll give some comments back, but if we don't fully answer somebody's question, or they have any, if you have any additional questions that you come up with, please feel free to email Damian or I. We're more than happy to make sure that we get you the answer that you need to understand your question.
Absolutely.
And thanks again. So we will say goodbye to all the participants, and the advisors and presenters will stay on. Thank you again.